Hi, hello there. Welcome to Designing Basic Enterprise Campus Network. The availability of a multi-gigabit campus switches gives customers the opportunity to build extremely high performance, high reliability networks if they follow correct network design approaches. Unfortunately, some alternative network design approaches can result in a network that has a lower performance, reliability, and manageability. This video describes a hierarchical modular design approach called multi-layer design. This video examines the design of the enterprise campus and the enterprise data center network infrastructures. First, it addresses general campus design considerations, followed by a discussion of a design of each of the modules and layers within the enterprise campus. This video concludes with an introduction to design considerations for the enterprise data center. Now, for the topic outline on designing basic enterprise campus networks, this video has been divided into three parts or segments. The first part would cover the campus design considerations. Next would be the enterprise campus design. Third would be the enterprise data center design considerations. And at the end of this video lecture, we are going to summarize each of the segment and the entire module. Campus design considerations. The multi-layer approach to campus network design combines data link layer and multi-layer switching to achieve robust, high available campus networks. So this section discusses factors to consider in a campus LAN design. Let's start with designing the enterprise campus. The enterprise campus network is the foundation for enabling business applications, enhancing productivity, and providing a multitude of services to end users. So the following three characteristics should be considered when designing a campus network. So this includes the network applications or network application characteristics. The organizational requirements, services, and applications place stringent requirements on a campus network solution, for example, in terms of bandwidth and delay. The next one would be the infrastructure device characteristics. The characteristics of the network devices selected influence the design. For example, they determine the network's flexibility and contribute to overall delay. So trade-offs between data link layer switching based on media access control or MAC addresses and multi-layer switching based on the network layer addresses, transport layer, and application awareness needed to be considered. So high availability and high throughput are requirements that might require consideration throughout the infrastructure. So most enterprise campus designs use a combination of data link layer switching in the access layer and multi-layer switching in the distribution and core layers. So the next one would be the environmental characteristics. Okay. Now, the network environment includes its geography and transmission media used. Okay? The physical environment of the building or buildings influences the design, as do the number of distribution, distance between the network nodes, including end users, hosts, and network devices. So other factors include space, power, heating, okay, or ventilation, and air conditioning support for the network devices. So cabling is one of the biggest long-term investments in network deployment. So therefore, transmission media selection depends not only on the required bandwidth and distances, but also on the emerging technologies that might be deployed over the same infrastructure in the future. Network application characteristics and considerations. So let's talk about the overview of the network application types. The network applications, characteristics, and requirements influence the design in many ways. So the applications that are critical to the organization and the network demands of the application. So determine enterprise traffic patterns inside the enterprise campus network, which influences bandwidth usage, response times, and the selection of the transmission medium. So different types of application communication result in varying network demands. So the following section review 4 types of application communication. So which are peer-to-peer, you've got the client local server, client server farm, and the client enterprise server or edge server. Now, these are the network requirements of applications. So this includes the connectivity type, the total required throughput, the high availability or HA, and the total network costs. Now, let's focus on the peer-to-peer application here. Okay, so from the network designer's perspective, peer-to-peer applications include applications in which the majority of the network traffic passes from one network edge device to another through the organization's network, as shown here in the figure. Okay, so a typical peer-to-peer applications includes the following, like the instant messaging. So after the connection is established, the conversation is directly between 2 peers. Okay, so you also have the IP phone calls. Okay, so 2 peers established communication with the help of an IP telephony manager. However, the conversation occurs directly between the 2 peers when the connection is established. The network requirements of the IP phone calls are strict because of the end of the quality of service or QoS treatment to minimize delay and variation in delay, or what we call jitter. So next would be file sharing. So some operating systems and applications require direct access to data on other workstations. Okay, so you also have the video conference systems. Okay, so video conferencing is similar to IP telephony. However, the network requirements are usually higher, particularly related to bandwidth consumption and, of course, the quality of service. Client local server applications. So historically, clients and servers were attached to a network device on the same LAN segment. And it follows the 80-20 workgroup rule for client server applications. So this rule indicates that 80% of the traffic is local to the LAN segment and 20% leaves the segment. So with increased traffic on the corporate network and a relatively fixed location for users, an organization might split the network into several isolated segments. Okay, so as shown here in the figure, you've got something like a building access, okay, and then you've got the building distribution campus core. Okay, so in here, each of these segments has its own servers known as local servers. Okay, so that is for each application. Now in this scenario, servers and users are located in the same VLAN, and department administrators manage and control the servers. Now, the majority of the department traffic occurs in the same segment, but some data exchange, okay, so to a different VLAN, happens over the campus backbone. Now, the bandwidth requirements for the traffic passing to another segment typically are not crucial. Okay, so for example, traffic to the internet goes through the common segment and has a lower performance requirements than traffic to the local segment servers. Another is the client server farm applications. So large organizations require their users to have fast, reliable, and controlled access to critical applications. Because high-performance multi-layer switches have a insignificant switch delay, and because of the reduced cost of the network bandwidth, locating the server centrally rather than in the workgroup is technically feasible and reduces support costs. So to fulfill demands, okay, and keep administrative costs down, the servers are located in a common server farm. So as shown here in the figure. So all the server of the organization was deployed on the server farm. So using a server farm requires a network infrastructure that is highly resilient. When you say resilient or highly resilient, it provides security and redundancy. Okay, so providing high availability, and that provides adequate throughput also. Now, high-end LAN switches with the fastest LAN technologies such as gigabit Ethernet are typically deployed in such environment. Okay, so typical applications, basically that includes mail servers, file servers, database servers, okay? And then access to applications, it should be fast, as I mentioned earlier, reliable and controlled, or it should be secure. Client server farm applications. Okay, now in a large organization, application traffic might have to pass across more than one wiring closets, okay, or the telecommunication closet, LAN or VLAN to reach server in a server farm. Now, client server farm applications apply the 20/80 rule, where only 20% of the traffic remains in the local LAN segment and 80% leaves the segment to reach centralized servers, the internet, and so on. So such applications includes the following. So such as the organizational mail server, so those who are using Microsoft Exchange, okay? Common file server, such as Microsoft and Sun Microsystems, okay? If there are still Sun Microsystems being used nowadays, but then most of us are using Microsoft operating system. Also, common database servers for organizational applications such as Oracle. Okay, so you also have the client enterprise edge applications. So shown here in the figure, client enterprise edge application use servers on the enterprise edge. Okay, that is to exchange data between the organization and its public servers. So the most important issues between the enterprise campus network and the enterprise edge are security, okay, and also the high availability. Data exchange with external entities must be in constant operation. All right. So applications installed on the enterprise edge can be crucial to organizational process flow. Okay, so therefore, any outages can increase costs. Okay, so next would be the relative network requirements by application type. So we have here on this table, okay, so it lists the types of application communication and compares their requirements with respect to some important network parameters. All right? So like connectivity. Okay, so let's start with connectivity here. Okay, so on connectivity, the wide use of LAN switching at layer 2 has revolutionized local area networking and has resulted in increased performance and more bandwidth for satisfying the requirements of new organizational applications. So LAN switches provides these performance benefits by increasing bandwidth and throughput for work groups and local servers. Now you have heard me saying throughput. Okay, so what is a throughput? So the required throughput varies from application to application. An application that exchanges data between users in the work group usually does not require a high throughput network infrastructure. However, organizational level applications usually require a high capacity link to the servers, which are usually located in the server farm. All right. So next would be high availability. So what is a high availability, or HA? The high availability of an application is a function of the application and the entire network between a client workstation and a server located in the network. So although the network design primarily determines the network's availability, the individual components, mean time between failures, or the MTBF, okay, that is a factor. Okay, so redundancy in the building distribution and campus core layer is recommended. Next would be the total network cost. So depending on the application and the resulting network infrastructure, the cost varies from low in a peer-to-peer environment to high in a network with redundancy in the building distribution, campus core, and server farm. Okay? So in addition to the cost of duplicate components for redundancy, cost includes, of course, the cables, right, routers, switches, software, and others. Environmental characteristics for network design. So what are the environmental characteristics and considerations? So the campus network environment, including the location of the network nodes and the distance between the nodes and the transmission media used, influences the network topology. So this section examines this consideration. Okay, so this includes the network geography, okay, or the network geography consideration. This pertains to the location of the enterprise campus nodes, and the distances between them determine the network's geography. Now, nodes including end user workstations and servers can be located in one or multiple buildings. Okay, so based on the location of the nodes and the distance between them, the network designer decides which technology should interconnect them based on the required maximum speed, distance, and so forth. Okay, considering the following structures with respect to network geography, so you've got sort of the intra-building, okay, inter-building, and distant remote building. Intra-building structure. An intra-building campus network structure provides connectivity for all end nodes located in the same building and gives them access to the network resources. The building access and the building distribution layer are typically located on the same building. Okay, so user workstations are usually attached to the building access switches in the floor wiring closet with twisted pair copper cables. So some are using wireless LAN or WLAN that can also be used to provide intra-building connectivity, enabling users to establish and maintain a wireless network connection throughout or between buildings without the limitations of wires and cables. Okay? Now, access layer switches usually connect the building distribution switches over fiber optic cable, okay, or optical fiber, providing better transmission performance and less sensitivity to environmental disturbances compared to copper. So depending on the connectivity requirements to resources in other parts of the campus, the building distribution switches may be connected to campus core switches. How about inter-building structure? Now, as shown here in the figure, an inter-building network structure provides connectivity between the individual campus buildings, central switches, that is in the building distribution and or campus core layers. Now, these buildings here, A and B, are usually in close proximity. So typically only a few hundred meters to a few kilometers apart. So because the nodes in all the campus buildings usually share common devices such as servers, okay, the demand for high-speed connectivity between the building is high. All right. So within the campus, companies might deploy their own physical transmission media. So to provide high throughput without excessive interference from environmental conditions, optical fiber is the medium. Okay. So that is basically to connect these two buildings here. So depending on the connectivity requirements to resources in other parts of the campus, the building distribution switches might be connected to the campus core switches. Distant remote building structure. So when connecting buildings at a distance or distances that exceed a few kilometers but still within a metropolitan area, the most important factor to consider is the physical media. Okay? So the speed and cost of the network infrastructure depends heavily on the media selection. So if the bandwidth requirements are higher than the physical connectivity options can support, the network designer must identify the organization's critical applications and then select the equipment that supports intelligent network services such as the QoS or the quality of service and filtering capabilities that allow optimal use of the bandwidth. Okay, so for the metropolitan-based network connectivity options, so using a company-owned fiber, okay, through the enterprise wide area network or through service provider offerings via your ISP. Campus transmission media. So let's talk about the transmission media considerations. So an enterprise campus can use various physical media to interconnect devices. So the type of cable is an important consideration when deploying a new network or upgrading an existing one. So cabling infrastructure represents a long-term investment. It is usually installed to last for 10 years or even more. Okay? So the cost of the medium, including the installation costs, and the available budget must be considered in addition to technical characteristics, such as signal attenuation and electromagnetic interferences. Okay? So the options would be, of course, the fiber optic or the optical fiber. So typically requirements that lead to the selection of the optical fiber cable as our transmission medium includes distances longer than 100 meters. And of course, the immunity to electromagnetic interferences. So different types of optical fiber or optical cable exist. So the two main types are, of course, the multi-mode or MM and the single mode or SM. Okay? Now, the difference would be MM or the multi-mode fiber is optical fiber that carries multiple light waves or modes concurrently. So each at a slightly different reflection angle within the optical fiber core. Now, because modes tend to disperse over longer lengths or modal dispersion, the multi-mode fiber transmission is used for relatively short distances. So typically, LEDs are used with a multi-mode fiber. So the typical diameter of a multi-mode fiber is 50 or 62.5 micrometers. Okay? So a single mode, also known as the monomode fiber, is optical fiber that carries a single wave or laser of light. So lasers are typically used with single mode fibers. So the typical diameter of a single mode fiber is between 2 to 10 micrometers. Okay? Now, single mode fiber limits dispersion and loss of light and therefore allows for higher transmission speeds, but it is more expensive than multi-mode fiber. So both multi-mode and single mode cables have lower loss of signal than copper cable. So therefore, optical cables allows longer distances between devices should use an optical fiber. Okay? So optical fiber cable has precise production and installation requirements. Therefore, it costs more than our traditional cable, which is the UTP or the twisted pair cable. Comparison of campus transmission media. So the parameters listed on this table are as follows. So basically you've got distance, bandwidth, and the price. Okay. Now let's take distance first. Okay. The maximum distance between network devices such as workstations, servers, printers, what else? IP phones, and network nodes, and between network nodes. Okay. The distances supported with fiber vary depending on whether it supports fast Ethernet or gigabit Ethernet, and the type of fiber used and the fiber interface used also. Okay, so it would depend whether you're using copper, the multi-mode fiber, the single mode, or even wireless. Okay, now for the bandwidth, the required bandwidth in a particular segment of the network or the connection speed between the nodes inside or outside the building. Okay, so another factor is price or cost. Along with the price of the medium, so the installation cost must be considered. Okay, so for example, fiber installation costs are significantly higher than copper installation costs because of strict requirements for optical fiber or optical cable coupling, right? So let's have an example here. Okay, so transmission media. Now this figure here illustrates a typical campus network structure. So each devices such as workstation, IP phones, and printers are no more than 100 meters away from the LAN switch. Okay, so UTP wiring can easily handle the required distance and speed. It is also easy to say that, well, this is the most economical solution. Okay, so to connect devices within the network or within the local area network. And the price performance ratio is, of course, reasonable. So optical fiber cables handle the higher speeds and distances that may be required among switch devices. So something like to connect this core switches here, then our option, best option, is to use the fiber optic cable. So multi-mode optical cable is usually satisfactory inside the building. Okay, so depending on the distance, organizations' use of the multi-mode or single-mode optical for inter-building communication cable, then it has to be considered. Okay, so multi-mode or single-mode, that's fine. All right. Now, if the distances are short, say up to 500 meters, multi-mode fiber is a more reasonable solution for speeds up to 1 Gbps. However, an organization can install single-mode fiber if its requirements are for longer distances, or if there are plans for future higher speeds, for example, 10 Gbps within the network. So when you design a network, again, you have to consider the future. So do not just design a network that is based on the current requirements. Okay, so you have to consider at least 10 years. Infrastructure device characteristics and considerations. So network and user devices are commonly connected using switch, okay, or the switch technology rather than using shared media segment. Okay, so switch technology provides a dedicated network bandwidth for each device on the network. So switch networks can support network infrastructure services such as the quality of service, okay, security, management, okay. A shared media segment cannot support these features. Now, in the past, LAN switches were layer 2 only devices. So So data link layer or layer 2 switching supports multiple simultaneous frame flows. The multi-layer switching performs packet switching and several functions at layer 3 and at higher open systems interconnection or the OSI layers, and can effectively replace routers in the LAN switched environment. Now, deciding whether to deploy a pure data link layer switches or a multi-layer switches in the enterprise network is not a trivial decision. Okay? So it requires a full understanding of the network topology and user demands. And basically, in network design, everything will boil down to cost. Now let's have an example of the network services. Okay, the quality of service in LAN switches. Okay, so when configuring the quality of service feature, classify the specific network traffic, prioritize and mark it according to its relative importance, and use congestion management and policing and shaping also, okay, to provide preferential treatment. So take note that in design, we have to give the highest priority to voice. Okay, so that is to ensure the quality of service. Now, implementing the QoS in the network makes the network performance more predictable and bandwidth use more effective. Now, this figure here illustrates where various categories of QoS may be implemented in the LAN switches. Okay? Now, data link layer switches are commonly used in the building access layer. Because they do not have knowledge of the layer 3 or higher information, these switches provides quality of service classification and marking based only on the switch's input port or MAC addresses. So, for example, traffic from a particular host can be defined as high priority traffic on the uplink port. Okay, so multi-layer switches can be used in the building access layer if layer 3 services are required. Now, building distribution, okay, or the building distribution layer, the campus core layer and the server farm switches are typically multi-layer switches, and that should provide the quality of service selectively, not only on the port basis, but also according to higher layer parameters such as IP addresses, port numbers, or quality of service bits in the IP packet. So these switches makes the QoS classification more selective by differentiating the traffic based on the application. So quality of service or QoS in distribution and core switches must be provided in both directions of the traffic flow. So the policing for certain traffic is usually implemented on the distribution layer switches. All right. So to summarize the campus design considerations, okay? So campus network design is influenced by several factors mentioned. Okay, so first, by application characteristics such as throughput and availability requirements. Second are environmental characteristics such as the location, okay, and buildings, okay, and of course the transmission media being used to connect these devices and buildings. And then third, the infrastructure device characteristics such as switching type and support for network services.